welcome once again. I think we'll be continuing with the same chapter, that is programming of 8085. Okay, I think till now we have already studied data transfer group of instructions, then logical group of instructions, arithmetic group of instructions, then we have already seen logical group of instructions and all. Now we are going with the branching group of instructions as well as. Now we are going with the next instruction group, that is machine control group of instructions. There are some divisions in this, but first we will try to understand stack operations from it. I think stack, everyone knows that, and we have already studied in data structures that it is working in a LIFO fashion, that is last in first out. Okay, and if I want you to draw a stack, then you can you have already seen that this will be a stack, okay, like this, and entry and exit, okay, that is whatever you want to enter here, that concept is known as push. Okay, if you want to enter something on the stack, we call it as a push, and if you want to remove anything from the stack, that is known as a pop. So there are two operations to be performed on the stack, that is push and pop. So push means to add something on the stack, and pop means if you want to remove something from the stack. So push RP, I think RP and this RP means register pair. So I think you already know we are having three pairs, BC, DE and HL. Okay, so push RP, push register pair on stack. So what happens in this? The contents of the contents of higher order register of register pair are moved to memory location whose address is one less than the content of stack pointer, and the contents of the lower order register of register pair are moved to memory location whose address is 2 less than the contents of stack pointer. Now don't get confused what is 1 less than the contents of register stack pointer and what is 2 less than the stack pointer. When we'll see the example, that time it will be more clear. All the instructions of this group are 1 byte and they belong to register indirect addressing mode. Okay, so I think this is about instruction information about byte, and this is about register indirect, that is addressing mode. Okay, now let's take an example of this. Now can you see push D? So in this case we will be having a DE pair. Okay, push means to add the data on the stack. So push register pair DE on stack. Push register pair in the sense the contents of register pair. Now I think you already know that whatever is written in square bracket, that means the contents. So right now the stack pointer is pointing to, and I think this is a stack as I was telling you, and can you see this is we have assumed that E00, E001, E002, that is the stack positions, or stack is nothing but a temporary memory location. Okay, now can you see right now your stack pointer is pointing to this address E002. So what is SP? SP means stack pointer. So stack pointer is a very important instruction which always stores the address of the top of the stack, and the contents of D and E are C0 and 06. So what happens in this is I think whatever the higher value is there, that means this is the higher value. Now just wait, I think in this case whatever the value of D is there, that will be going to E001, and whatever the value of E is there, because this is lower order, that will be going to the E000, and stack pointer will be pointing to this position. So whenever you add something on a stack, stack pointer is always decremented by 2. Okay, now can you see initially stack pointer was at stack pointer was initial position was E002, that is before execution. Now whatever you can see on the screen, that is after execution. So after execution, can you see it has moved to here. So right now the stack pointer was at E002, now it has moved to the E000. So that means stack pointer is, whenever you perform a push operation, stack pointer is always decremented by 2. So that means whenever you add something on a stack, what do you mean by push? to add the data on the stack. Okay, so right now we are adding the contents of DE pair according to the instruction, because you can use any of the pairs, but here we are using only DE pair. So the contents of D will be put first and then the contents of E. Okay, so I hope you can see contents of E001 will be C0, contents of E000 will be 06, and the stack pointer will be pointing to this position, that is E000. So I hope you understood. Now we are also having push PSW. Now what do you mean by PSW? PSW sometimes also stands for processor status word. Now status indicates flag register. So I think till now you have seen only 3 types of pairs, that is HL, DE and BC. Now there is a new pair which is coming up known as A and F. Okay, so AF is also going to be the new pair, and that pairing is also known as PSW. So can you see we call as PSW means accumulator as well as flag contents. Okay, the contents of accumulator are moved to memory location whose address is, now can you see, instead of register pair we are having accumulator has moved to the whose address is less than the contents of stack pointer. The contents of processor status word, that is flag, are moved to the memory location whose address is 2 less than the contents of the, that means this is your lower order and this is your higher order. Stack pointer is decremented by 2 here also because it is a push operation. A and F, A stands for accumulator, F stands for flag, are the new combination of register pair, and same thing, all the instructions are 1 byte, they belong to register indirect addressing mode. So I hope you understood this. Now let's take an example. Now can you see push PSW? Now whatever the contents of accumulator and flags, so I just kept the same thing. Contents of accumulator are C0, contents of stack F, that is flag, is 06. Stack pointer right now is pointing to E002. Now this is before execution scenario. Now what happens after execution? Whatever the value of, 1 minute, whatever the value of here, the value of accumulator will be inserted, and because flag is a lower order, that's why the flag value will be at this position, and stack pointer, can you see, is moved to E00, and in this case also stack pointer is always decremented by 2. So I hope you understood. This instruction is similar to the first instruction only, but instead of any other pair we are having accumulator and flag. That is the only difference. Okay, rest everything is same. Okay, in this case you can just replace any of the registers like BC, DE or HL, but here it is fixed. What are the PSW stands for? Accumulator and flag. Okay, now let's do the reverse process. Pop means if you want to remove something out of the stack, that is pop of stack to register pair. So exactly it will be working opposite of push. The contents of memory location whose address is specified in the stack pointer are moved to the lower order register pair. The contents of memory location whose address is 1 less than the contents of register pair stack pointer are moved to the higher order register of register pair. Okay, so stack pointer is incremented by 2. Okay, because you are just reversing this, so stack pointer will be incremented by 2. Whenever you add something on the stack, stack pointer is decremented, but whenever you remove something from the stack pointer is incremented by 2. Any of the pairs, like you already know, B, C, D and HL, same thing, all the instructions are 1 byte, they belong to register indirect addressing mode. Okay, now can you see we have taken the different example, pop H. So let's take stack pointer is pointing to this position. Okay, 2001, and the contents of HL pair, now can you see, is C0 and L is 06. Now what happens in this case, contents of HL pair will be changed. So whatever is there in the first memory location, I think it is exactly like that only. whatever the contents of first memory location, that will be given to the lower order, and whatever the second order second memory location, that will be given to the higher order. Okay, and stack pointer will be pointing to the new position, that is 2003. So in this case what happens, stack pointer is incremented by 2. Okay, can you see here, initially it was at 2001, now it has been moved to the 2003. So exactly same thing, but only the stack pointer is we are adding the data, that's why stack pointer will be incremented by 2. In that case it is decremented by 2. Let me check. Yeah, can you see here it is decremented by 2, but here you can you see here it is incremented by 2. Now same operation, let's take an example. I think example we have taken. So the contents of HL pair will be changing. Instead of C0 and 06, it has been changed to 20 and 10. Okay, now let's go with the same thing, but I think this will change the contents of accumulator and flag. Okay, pop of stack, accumulator and flag register. The contents of memory location whose address is specified the contents of register stack pointer are used to restore the condition of flags. The contents of memory location whose address is 1 more than the stack pointer are moved to the accumulator. Stack pointer is incremented by 2. All the instructions are 1 byte and they belong to register indirect addressing mode. Now here you can see pop PSW. So accumulator contains, can you see, I have just taken the same example because I don't want to draw the diagram again. Okay, so accumulator content is C0, flag content is 06. So what will happen? Lower order will be going to flag and higher order will be going to the accumulator, and stack pointer will be incremented by 2. I think you can easily understand. Okay, this will go here, and initially stack pointer was at 2001, now the stack pointer is 2003. So stack pointer is incremented by 2. So I hope you got it. So stack pointer operations like push and pop are almost over. Now let's see what is there in other than push and pop. We are having XTHL. X, whenever the X word comes, that means you have to use pair, and whenever the X comes at the start, that means exchange will take place. Exchange HL with top of stack. The contents of L register are exchanged with the contents of memory location whose address is stored in the stack pointer. The address of H registers are exchanged with the contents of memory location whose address is 1 more than the contents of the stack pointer. Contents of stack pointer are not altered because we are not performing any push and pop operations. We are just exchanging. All the instructions are 1 byte, but they belong to register indirect addressing mode. I think it is similar to that. Now can you see XTHL, that is exchange HL and top of stack. So what happens in this case, H and L value is 30 and 40 and stack pointer value is 10 and 20. So can you see 10 and 20. So after this the values will get exchanged. Now can you see here, 1 minute. So here you can see that stack pointer value, initial values of stack pointer is 10 and 20. So the values of stack will be, H value will be given to this, and L value is given here. Okay, so can you see stack pointer will be taking these two values, and stack pointer will take the values of program counter, not program counter, HL values. So HL values will be 0 0. So contents will change, not the stack pointer values. Okay, not the stack pointer. Okay, the contents of stack pointer will change. So initially it was 10 20, now it is 30 40. Okay, now let's go with the last instruction of this group, SPHL, that is move HL to SP. This instruction copies the contents of register L into lower order byte of stack pointer and the contents of H register into the higher order byte of stack pointer. The contents of H and L are not affected. I think in this case it is affecting both, but in this case only stack pointer will be affected, not the HL pair. This instruction is used for initializing the stack pointer. All the instructions are 1 byte, they belong to register addressing mode. Okay, so can you see L value move to the stack pointer lower order, H value is moved to the stack pointer higher order. So HL values are 25 and H value is 25, L value is 59 and stack pointer value is 12 and 34. So what will happen in this case? I think this will come directly here. So whatever the value, first 25 will go and then 59, because this is lower order and this is higher order. I hope you understood all the operations from the stack, like push, pop, but push and pop can also be done with PSW, that is processor status word. In that we are having a new pair combination, that is accumulator and flag. Then we have seen XTHL and finally we have seen SPHL. So I hope we have just finished with all the stack operations, but I think this chapter is still not over. We will be having some more instructions from this group. So I hope you understood till here. We'll meet some other time. Thank you.